This is for Year 11 methods. We're going to look at exercise 18H, question 4. So consider the following cubic function with this equation. Now, with these questions, it's always a good idea to have in your mind or draw a quick drawing of what the graph actually looks like. So we've got a bounce at A and a cut at 1, okay, and it's a positive cubic, so it's going to have this shape. And we know A is greater than 1. That's useful because the location of the bounce would be after 1. So we've got 1, we've got A, and the cubic's a positive cubic. So we've got a cut at 1 and a bounce at A. So it's going to look something like that. So that might be useful later on, okay? So this is the original graph of f with respect to x, okay? Find the quantity of the turning point of the graph f of x. Okay, so this is where you use a calculator to find f dash of x. So f dash of x will derive that. Remember, just because there's a letter in our equation doesn't mean we can't derive it. So let's go and derive it. So we've got x minus a. So to get the a, you go to the VR menu. Do not go to the ABC. X minus 1. Okay, I'm going to derive that. So interactive calc differentiate, okay? And you can simplify to make the answer nicer. So it will be x minus a, 3x minus a minus 2. X minus a, 3x minus a minus 2. So that's the derivative. We want to find the quantity of the turning point. So let f dash x equals 0. So we want to solve that because the turning points occur only when that happens. So we're going to let this equal 0. I'm going to go solve. And solve. So, and we'll want to simplify our answer. So it's a plus 2 on 3 and x equals a. So at x equals a and x equals a plus 2 over 3, there are turning points. And we need to find the coordinates of the turning point. So we need to find the corresponding y value. Okay, so let's do a sub in. Alright, so the original, it's really important that you sub back into the original. We're just subbing back into the derivative, okay? That'll be incorrect. So if I sub into the original, so I'm going to go given that x equals a plus 2 on 3, what do we get? Can we simplify it further? Yep. 4a minus 1 cubed on 27. So we've got a plus 2 on 3. Can't remember what it said. So 4a minus 1 cubed on 27. 4a minus 1 cubed on 27 is my first turning point. My second turning point, we go here, and I want to substitute, so I'm going to copy and paste this. Instead of this, I want to sub in x equals a, that's my second turning point, and happens to be 0, so that would be a0. So we've got two turning points, one's at a0, one's at this turning point, okay? So we've done that. State the nature of the turning points. So we've got two turning points, right? So a at x equals a will have a maximum, no, not maximum, minimum, because if we look back at my original graph, can we see that x equals a is a minimum? That's when the y value is 0. So that we know from the original graph, a0 is a local max, and this must be local min, this must be the local maximum. Purely because I've drawn the graph of it, okay? So if you draw a graph and refer back to it, that should be sufficient for the SAC, okay? So it should be okay for me. Find the equation of the tangent at which x equals 1, a, and a plus 2. Okay, so we've done a, we've done b, we're just trying to find the tangent at these points. So tangent's pretty simple. We actually, all we need is original and sub in the points. Okay, so let's go, this is the original equation. I want to find the tangent at these three various points. So what you do is you go, I'll highlight, we go calculate line, tan line, and we want the tangent at 3 different points, so one's at x equals 1. Done. Let's see if we can simplify it. So x minus 1, a minus 1 squared. So the first tangent, c part 1, x minus 1, a minus 1 squared. So y equals, that's the first equation of the first tangent. Part 1, part 2, you sub in a. So instead of tan line at 1, we want the tan line at a. So I'm going to just reuse this command. Oops, wrong, go to VR, a. Tan line is equals a. It's y equals 0. So since we have 0, it means y equals 0, and then 3, oops, 3, a plus 1 on 2. A plus 1 on 2. I don't even need to work out the tangent line on part 3 because, actually I do. The reason why the tangent line at x equals a is 0 because at x equals a, what do we have? We have a turning point, so tangent. We know the gradient of a turning point 0, so the tangent must have a gradient of 0, so that's why it's y equals 0. For 3, you just go a plus 1 divided by 2, so I'm going to use a fraction button, a plus 1, it's a plus 1 divided by 2, and we simplify the expression because that looks a bit nasty, so we get y equals minus x minus a minus 1. Okay, so minus x minus a minus 1 squared divided by 4. I think that's what it said. Just double checking. X minus a. Yep, that's good. Okay, so we've got the tangent line. Remember, we always put the y equals to. So this question is a bit tricky because we've got a parameter, but like I said, you can treat parameters as if they're normal numbers and sub things in to get your corresponding minimums and maximums. And to get the tangent and to state the nature, you just simply draw the original graph. So all you need to show that to me is that, hang on, I know that A0 is a max minimum based on the original graph, and this is the local maximum based on the fact that, you know, if we already used up the minimum, the leftover is the maximum. For finding equations of tangents, just simply sub in your values and use the tan line command. Okay, so hopefully that helps.